Hi, I'm Stevie C and the place to be. In this video, I'm going to be assembling my We Make Events PCB that I designed and had manufactured to help show support for the hashtag We Make Events campaign. I just ran out of time to place my order, meaning I had to do a different video instead, which I'll provide a link to. As usual, I designed the board in Sprint layout and sent the designs to JLCPCB for manufacture. If I've edited this video correctly, you'll now see a small error in the outline of the PCB. I only noticed this myself after sending the Gerbers off to the manufacturers, but their engineering team caught it and corrected it. So, thanks for that, JLCPCB. Oh, and thanks for the keyring. The PCB uses 225 LEDs to spell out the We Make Events motto, split into two roughly even series circuits fed from capacitive droppers. In theory, any colour of LED can be used, but I'll be using red for this demonstration as it fits in with the whole Light It in Red theme. If you're wondering, the hashtag We Make Events campaign was about live events workers across the UK and beyond lighting up buildings and attempting to raise public awareness and support for the live events industry, because we need support to survive lockdown. We've paid billions into the economy and yet have been largely ignored. Not forgotten about, actively ignored. Myself and a work colleague lit up the Reed Park in Forfar using a pure sine wave inverter and car battery as a power source. So, back to the PCB. I designed it with the dimensions of a B&M Home Store's 8x10 picture frame in mind. Even though the campaign has now passed, assuming you ignore the fact that we're still being largely ignored by the government and media, I just thought it would be nice to have something to put on your desk or in your warehouse or in your workshop, etc. As the design uses 5mm LEDs instead of 3mm ones, it should be a lot easier to solder than the Jojoba Bunny PCB. The sets of LEDs are designed to run at low current with either a 100, a 47, or even a 22 nanofarad dropper capacitor. There is an inrush limit resistor, a full wave bridge rectifier, an electrolytic capacitor for smoothing, and provision for discharge resistors across all the capacitors. I sourced all the LEDs from eBay. All the other components are sourced from Rapid Electronics and are therefore rated for our mains voltage. So first of all, I'm going to install the resistors and then the LEDs, and then the rest of the power supply components. So let's cut to time-lapse and cue the music. So now it's time to test this. I genuinely don't know if this will work or go kablamo, but I'm doing the same thing as last time. I'm relying on the discharge resistors to trickle a small amount of current through, just enough to light the circuit. Actually, hold on. Just hold that in your heads while I test it. So here we go. Nothing. Oh. Okay. Okay, take two. Okay. Keens. Ike Ians. There you go. Okay. Yay! So I've got one LED that's a bit more powerful than the rest of them. I'm not quite sure why. It's not the angle. Anyway, as you can see, it's pulling just over a watt. So that's my #WeMakeEvents PCB with red LEDs. I was considering selling a few of the boards if anyone's interested. If you like this video, please click like. If you aren't already subscribed, please click subscribe because it helps the channel. If you have any suggestions for future videos or comments about this one, stick a comment down below. And until next time, thanks for watching.